Hello everyone, I'm welcoming all of you all once again to your very own chemistry guide, Utsav's ChemTrek. Today's video happens to be extremely special for me because for the first time I'm going to reach my audience in the 8th standard, and the chapter that we are starting with today kind of lays down the foundation for your entire 8th standard chemistry academic year. आज का वीडियो स्पेशल इसलिए भी है because there's going to be a lot of learning with a lot of interesting demonstrations. So without wasting much time, let's go to our learning station. So the chapter that we're beginning with today is called as matter. Now what we're going to do is we are going to jump right into the definition of the term matter. It's there onto the board. Have a look. Matter is considered to be anything that occupies space, has a mass, and it can be perceived by our senses. Now I want you all to remember something for me which will be extremely useful for us in the latter part of the video. Remember that anything that occupies space will have a volume, and anything that has mass will also have a weight. Now in this particular part, I have discussed that matter occupies space. It also has a mass. And now I'm going to tell you all that matter can be perceived by our senses. And for that, I'm going to use this bar of soap as an example. How many senses do we have? A total of 5. The first one is eyes. Yes, I can definitely see the bar of soap. Second is nose. It has a brilliant odor to it. So in this particular case, there's a sense of smell. Ears. I can definitely hear this bar of soap as well. Tongue. Okay, now I guess that's not really advisable, but just like all other bars of soap, I expect that even this one is going to be bitter in taste. And finally, we have skin. So I can definitely feel it, and there's a sense of touch. That being said, all of the information that you require is there onto the board. It's time for you all to take a snapshot. So now, in this particular part of the video, I'm going to discuss something called as the characteristics of matter. In the previous part of the video, I had told you all to remember the fact that anything that occupies space will have a volume. So volume is actually nothing but the space occupied by matter. For example, if I talk about this bar of soap, in this room, there is a particular space which is only and only occupied by this bar of soap. And the space occupied by this bar of soap is its volume. After that, remember that mass is the quantity of matter. किसी भी ऑब्जेक्ट में जितना ज्यादा मैटर होगा, उसका मास उतना ही ज्यादा होगा. After that, remember, anything that has mass will also have weight. And what is weight? Weight is the gravitational pull on matter. This particular bar of soap already has mass, and that particular mass is attracted by gravity into the downward direction. The gravitational pull on matter is called as its weight. Remember that matter can also be perceived by our senses. For example, smell and touch. But that is something that we had already discussed in the previous part of this video. The information that you all require is there onto the board. Time for you all to take a snapshot. Now, in this part of the video, we are going to discuss something called as the composition of matter. Matter can normally be made up of a total of 3 kinds of particles: atoms, molecules, or ions. And right now, I am going to give you all the definitions of all of these 3 with examples. Let's start. An atom is the smallest particle of an element that takes part in a chemical reaction. If I ask you all, how do you represent a single atom of oxygen? Your answer should be that a single atom of oxygen is represented by the letter O. In a similar manner, a single atom of hydrogen is represented by the letter H, and a single atom of chlorine is represented by the letter Cl. The problem with most of the atoms is that they cannot exist independently. वो लोग अपने आप से रह नहीं सकते. तो atoms करते क्या है? They tend to combine. Here I have my first atom. Here I have my second atom. अगर इन दोनों के बीच में मैं बना दूं bond, तो मेरे पास आ जाएगा molecule. Now what is a molecule? The molecule is the smallest particle of a substance capable of independent existence. वो खुद से रह सकता है. And at the same time, it retains the characteristics of the substance. Now for example, I have an atom of oxygen. I have another atom of oxygen. They combine together. I will get a molecule of oxygen which is represented by O2. In a similar manner, atom of hydrogen combine कर देंगे तो बन जाएगा molecule of hydrogen which is represented as H2. And lastly, atom of chlorine combine कर देंगे तो बन जाएगा molecule of chlorine capable of independent existence and represented as Cl2. Now, for the last part, we are going to discuss something which is called as an ion. Now, what is an ion? An ion is an atom or a group of atoms that has a charge due to the loss of electrons or gain of electrons. Now, understand this particular thing very carefully. This over here is an atom of oxygen. But if I write O with a charge of 2 minus, it becomes an ion of oxygen. In a similar manner, I have an atom of hydrogen. But if I represent it as H with a charge of 1 plus, it becomes an ion of hydrogen. And lastly, here I have an atom of chlorine, and if I give it a charge of Cl with a charge of 1 minus, it becomes an ion of chlorine. All of the information that you require is there onto the board right now. It's time for you all to take a snapshot. Now, in this part of the video, I am going to explain to you all an extremely important differentiation table between the three states of matter, which are solids, liquids and gases, with respect to a total of 8 characteristics which are right now mentioned onto the board. And to explain to you all the differentiations, I am going to have some extremely interesting demonstrations for you as well. Now remember, as far as the first 2 points of differentiation are considered, I have already told you all that matter is anything that occupies space and has a mass. अब इसका मतलब ये है that be it a solid, be it a liquid or be it a gas, all of the 3 states of matter are going to occupy space and they are going to have a mass. Which means, what are we going to do over here? We have made the information appear for you all on the snap of my fingers, stating that be it a solid or a liquid or a gas, all of them are going to occupy space, and in a similar manner, be it a solid, a liquid or a gas, all of them are going to have a mass. So let's talk about the volume and the shape of the first state of matter, which happens to be a solid. And for demonstrating that over here, I have a perfect cube. Now, when you talk about the volume of this particular solid, it is basically the space occupied by this particular cube. In this entire room, there is a certain amount of space, a definite amount of space, which is only and only valid for this particular cube. Yani ki it occupies a definite amount of space, yani ki it occupies a definite amount of volume. At the same time, आप कितना भी कुछ भी कर लो, इस क्यूब का शेप आसानी से चेंज होने वाला नहीं है, which means all solids have a definite shape as well. So solids have a definite volume and a definite shape. So now let's talk about the volume and the shape of the second state of matter, which happens to be a liquid. Now, for that, I have a total of 2 bottles over here. The interesting factor is that both of them have the same volume capacity, which is 250 ml, but yet they have a slightly different shape. Now what I'm going to do is I'm going to pour the water which is there in the first bottle over here. I've added a small amount of red dye to it so that you can see it clearly, and right now it is filled up to the brim. Yani the quantity of water is exactly 250 ml. Very carefully, what I'm going to do is I am going to transfer the entire liquid quantity into the second bottle over here. And if you'll see very carefully, while I'm doing that, it starts to fill up to the brim. Here also the volume of the liquid touches the surface, touches the brim over here, which means the volume happens to be exactly the same, exactly 250 ml. But it was seen that the shape of the two bottles was different, which means liquids will have a definite volume, but they will have a non-definite shape. The shape will depend upon the shape of the container in which they are stored in. So now let's talk about the volume and the shape which is occupied by a particular gas. As you all can see onto your screens right now, I have a total of two different glass containers. That happens to be the first one, and this one happens to be the second one. The observable thing about both these glass containers is that the volume and the shape of them happens to be completely different. Over here I have something called as a backflow incense burner, and what exactly is that I'll be telling you all in the next part of this video. The amazing thing about a backflow incense burner is that normally agarbatti ka jo dhua hai that goes into the upward direction. However, as far as a backflow incense burner is considered, the moment I put it onto the test tube, you all will be able to observe that the smoke of this particular thing travels into the downward direction. So the moment I put it over the test tube, the smoke from the backflow incense burner travels into the downward direction. Now if you all see, slowly the incense is actually filling up the entire test tube, and it is occupying the volume and the shape of the container. If I shake the test tube a little bit, you all will be able to notice that the incense continues to go in the downward direction. After some time, the smoke has now completely filled the test tube. So I remove the incense, take up the test tube, remove the clay holding, and now I will attempt to transfer the entire smoke into the second container. As you all can see, now the smoke occupies the shape and the volume of the second container. So from the demonstrations, you all must have understood the fact that solids have a definite volume as well as a definite shape. Liquids have a definite volume but do not have a definite shape because their shape depends upon the container in which they are stored in. And a gas neither has a definite volume nor has a definite shape, because for a gas, the volume as well as the shape depends upon the volume and the shape of the container in which the gas is stored in. Coming on to the next concept, which is called as density. Now density actually has a formula. It is given by the formula mass upon volume, and it is a measure as to how heavy a particular object is. ये हमारा एकदम जनरल तरीका है जानने का that solids काफी भारी होते हैं, which means solids का density happens to be extremely high. Liquids are relatively lighter, which means the density of a liquid is lesser than solids. And as far as gases are considered, they are supposed to be the least heavy, which means they are going to have the least amount of density. अब इस demonstration से आपको ये समझ में आया होगा that solids have a high density, liquids have less density, and gases have the least density. The next phenomena that we're going to talk about is called as compressibility. So if I take a solid over here and from both sides I apply a lot of amount of force or I apply a lot of amount of pressure, I see कि ये solid compress होने वाला नहीं है, which means solids are incompressible. Now As far as the liquid is considered, what have I done is, I have taken a syringe over here and I have withdrawn over here a small amount of water in which I have put red ink so that you all can easily see. Now what I'm going to do is, I'm going to attach my thumb over here and take it as close to the camera as possible. If I apply a force into the downward direction, you all will see that the syringe moves very slightly into the downward direction. तो क्या liquids को compress किया जा सकता है? हाँ, but liquids are slightly compressible. Now say suppose मैं इस syringe में से सारा पानी निकाल देता हूँ, and in this particular case what I'm going to do is I'm going to take it into the upward direction. मतलब मैंने यहाँ पे air भर लिया है. Now in the same way I'm going to put my thumb over here and I'm going to push this thing into the downward direction, and here I'm quite successful. But at the end काफी pressure ज़्यादा हो जाता है. जैसे ही मैं इसको छोड़ता हूँ, it bounces back. So gases can be compressed और काफी ज़्यादा compress कर सकते हो. So gases are highly compressible. I hope you all like that demonstration. और इस demonstration से हमें ये समझ में आया that solids cannot be compressed, liquids are slightly compressible, and gases are highly compressible. Now the next differentiation over here is with respect to something which we call as number of free surfaces, which is the number of surfaces that you can actually touch, जिन्हें आप actually छू सकते हो. Let's talk about a solid. Say suppose I have a solid over here and it's a cube. So how many free surfaces will it have? A total of 6. There's 1, 2, 3, 4, 5 and 6. However, in this particular case, understand that if I take my book as an example, how many free surfaces will it have? 1, 2, 3, 4, 5 and 6. But if I open this particular book, I have 7 and 8. I again open it, 9 and 10. और इसी तरीके से number of free surfaces in a solid का कोई upper limit नहीं है. It can have any number of free surfaces. अब liquid की तरफ जाते हैं. I have a beaker over here जिसमें मैंने water दिया है with a small amount of red ink. The only surface of the liquid that I can actually touch is the upper surface. This particular surface I can touch. So liquids के अंदर एक ही surface होता है और उसको हम बोलते हैं one upper free surface. और जहाँ तक gases के बारे में बात है, you can't really touch a gas. तो gases के पास कोई भी free surface होने वाला नहीं है. So now we know that solids have any number of free surfaces. कितने भी हो सकते हैं. Liquids have only one upper free surface, and gases do not have any free surfaces. Our next differentiation is with respect to something called as diffusion. If you have two objects and they tend to mix with respect to each other, तो हम बोलते हैं that they are diffusible in nature. Let's talk about solids. I have my first solid over here, which is plastic, and the second, which is also plastic cube. If I try to push them against one another, will they actually combine? No. Which means solids को हम diffuse कर सकते नहीं हैं. On to the other hand, let's talk about a total of 2 test tubes over here, which have 2 liquids. The first one over here contains water, जिसमें थोड़ा dye है, and the second one contains oil. Now, if I pour oil into the test tube over here, are they going to mix? No. So in this particular case, this is an example of दो liquids जो miscible नहीं है. They do not tend to mix with respect to each other. They are immiscible. But at the same time, if I take water in the first one and I've taken ethyl alcohol in the second one, which happens to be a clear colorless liquid, and if I mix them with respect to each other, ये दोनों एक दूसरे में mix हो जाते हैं. मतलब they show diffusion. They are miscible liquids. They easily mix with respect to each other. So liquids mix हो भी सकते हैं और नहीं भी. And finally, I have gases. In this particular case, I have a deodorant over here. If I spray it, it will easily mix with the air. तो जहाँ तक gases के बारे में बात है, they are considered to be freely diffusible. वो हमेशा mix हो जाते हैं. अब इस last demonstration से हमें ये समझ में आया that solids cannot diffuse, liquids show diffusion. पर हर एक liquid diffuse करेगा ऐसा जरूरी नहीं है. And gases very easily diffuse. All of the information that you all require for this differentiation table is there on the board. It's time for you all to take a snapshot. Now, in this part of the video, we are going to discuss the main postulates of the kinetic theory of matter. Within the kinetic theory of matter, we have a total of 3 points. We have a total of 3 postulates. What are these 3 points? Let's have a look. The first one is going to be interparticle space. The second one will be interparticle force of attraction. And the last one is going to be kinetic energy. Let's have a look at the first one, which is called as interparticle space. अब इसे explain मैं कुछ इस तरीके से करता हूँ. Let's assume this is your first particle. This is your second particle. अगर मैं इन दोनों particles को बहुत close भी लेके आ जाऊँ, उसके बावजूद इन दोनों particles के बीच में थोड़ा बहुत space रह जाता है और इस space को मैं बोलता हूँ interparticle space. Let's have a look. यहाँ पे space between particles is called as interparticle space. ऐसा होता क्यों है? क्योंकि the particles are always arranged in a way कि वहां पे हमेशा थोड़ा बहुत space रह जाता है. That is, the particles are arranged in a manner that they have spaces left between them. After that, we have something called as interparticle force of attraction. This is my first particle. This is my second particle. And between these two particles, there will always be a force of attraction. ये interparticle force of attraction किस पे depend करता है? It depends on the interparticle space. Interparticle space जितना कम, force of attraction उतना ही ज़्यादा. Interparticle space जितना ज़्यादा, force of attraction उतना ही कम. Let's have a look. All particles are always going to attract each other. Attraction happens to be maximum if the particles are close. Attraction happens to be minimum if the particles are far. And the last thing that we're going to discuss over here is called as kinetic energy. Understand one thing very clearly. किसी भी object के पास, किसी भी particle के पास हमेशा दो तरीके की energies होती हैं. Potential energy or kinetic energy. If a body is in a state of rest, वो बिल्कुल भी move नहीं कर रहा है, stationary है, तो that it has potential energy. But if a particle is moving, if it is in a state of motion, then it will have kinetic energy. और इस वक्त हम सिर्फ और सिर्फ kinetic energy के ऊपर focus करने वाले हैं. Understand that all particles are always in a state of random motion. They will always continuously move. They will always continuously vibrate. अगर vibration कम है, तो kinetic energy भी कम है. अगर vibration ज़्यादा है, तो kinetic energy भी ज़्यादा है. Let's have a look. Particles are always in a continuous motion. Understand, application of heat increases the kinetic energy because particles will move more randomly. तो अगर मैं एक ऑब्जेक्ट ले लूं और मैं उसको सप्लाई करूं हीट, तो वो उस हीट को कर लेगा एब्सॉर्ब. उसके बाद उसके वाइब्रेशंस बढ़ेंगे. More the vibrations, more will be the kinetic energy. And in this particular manner, we have finished the concept. All of the information that you require is there on the board. It's time for you all to take a snapshot. Now, with respect to the kinetic theory of matter, we are going to have another small differentiation table with respect to solids, liquids and gases. But don't worry, even to understand this particular differentiation table, we have some interesting demonstrations coming up for you all. So now let's talk about the kinetic theory of matter with respect to solids. Consider कि ये जो 4 magnets आपको दिख रहे हैं, those are particles of solids. Solids के केस में the particles are packed really closely to each other. तो ऐसे केस में the amount of space between them, the interparticle space is going to be extremely small. Particles जितने पास होंगे, force of attraction जैसा आप देख सकते हो उतना ही ज़्यादा होगा. So the force of attraction in the case of a solid is extremely high. Now say suppose I take these 3 particles together and if the 4th one moves, उसको ज़्यादा freedom नहीं है move करने के लिए, which means the kinetic energy, the vibrational energy is going to be minimum. With that demonstration, you all have understood that in the case of a solid, the interparticle space is minimum, the interparticle force of attraction is maximum, the kinetic energy happens to be the least, and the movement of atoms is possible but only about their mean positions. Now let's assume the particles that you'll see over here, they are with respect to liquids. Now if you'll see, space बढ़ गया है, so the interparticle space will be more as compared to a solid. अगर स्पेस बढ़ गया है तो फोर्स ऑफ अट्रैक्शन रिलेटिवली कम हो जाएगा, और यहाँ पे लिक्विड के पार्टिकल को काफ़ी ज़्यादा फ्रीडम है मूव करने के लिए, सो इट विल बी एबल टू वाइब्रेट अ लॉट. और अगर वो काफ़ी ज़्यादा वाइब्रेशन दिखाएगा मतलब द काइनेटिक एनर्जी विल बी रिलेटिवली लार्जर एज कम्पेयर टू अ सॉलिड. That demonstration of a liquid proved to us that the interparticle space is more than solids. The interparticle force of attraction is less than solids. The kinetic energy is large and the movement of atoms is definitely there. It happens to be in continuous motion. Now in the case of gases, these particles will move even further away from each other. Space बहुत ज़्यादा है, so the interparticle space in a gas will be maximum. पार्टिकल्स जितने दूर जाएंगे फोर्स ऑफ अट्रैक्शन हो जाएगा उनका इतना ही कम, सो द इंटरपार्टिकल फोर्स ऑफ अट्रैक्शन विल बी द लीस्ट इन द केस ऑफ अ गैस. एंड ऑल ऑफ दीज पार्टिकल्स दे हैव अ लॉट ऑफ फ्रीडम ऑफ मूवमेंट. वो किसी भी डायरेक्शन में आसानी से मूव कर सकते हैं बिकॉज देयर सो मच अमाउंट ऑफ स्पेस अवेलेबल. इसका मतलब वाइब्रेशनल एनर्जी जो है, काइनेटिक एनर्जी जो है, इट विल बी मैक्सिमम. And with respect to the last demonstration in this particular part of the video, you all must have understood that as far as gases are considered, the interparticle space happens to be extremely large. The interparticle force of attraction is relatively negligible, that is almost non-existent. The kinetic energy also happens to be very large, and as far as the movement of atoms is considered, it happens to be in any random direction. That fills up the board completely. It's time for you all to take a snapshot. So now let's discuss the topic which is making the board appear so beautiful right now. The topic over here that we are going to discuss is called as the interconversion of matter. This topic basically explains to us that all three states of matter, be it a solid, a liquid or a gas, are all interconvertible. And that means that a solid can be converted into a liquid. A liquid can be converted into a gas. But at the same time, the reverse is also possible, which means, practically speaking, you can also convert a gas into a liquid and a liquid again into a solid. Now remember this thing very carefully. Whenever you convert a solid into a liquid, the process can be called as either melting or fusion. In a similar manner, when you convert a liquid into a gas, the process can be called as boiling or vaporization. On to the reverse side, when a gas is converted into a liquid, the process can be called as condensation or liquefaction. And when a liquid is reconverted back to a solid, the process is called as freezing or solidification. Now understand one thing very carefully over here. Sometimes, in certain cases, it is also possible to take a solid, directly convert it into a gas when you skip the liquid phase entirely. That process is called as sublimation. In a similar manner, you can start with a gas, directly convert it into a solid without passing through the liquid state. And that particular process, depending upon the kind of school you are in, is either called as deposition or it can also be called as reverse sublimation. All of the things that you all require are there onto the board. So you all know what? It's time for you all to take a snapshot. Now, in this part of the video, we are going to discuss in detail every process that you all just studied about with respect to something called as the kinetic theory of matter. Understand that in this part of the video, we are going to fundamentally discuss a total of two processes which are very much similar to each other. The first process is called as melting, or you can also call it as fusion. And the other process is called as boiling, or you can also call it as vaporization. Let me explain only the first part over here, and the second part is something that you all will be able to automatically learn let's begin. As far as the first process, melting or fusion is considered, to initiate the process, to start the process, what are you going to do? You're going to supply something called as heat energy. When you supply heat energy, the temperature is going to rise. The particles of the solid will absorb the heat energy and convert it to kinetic energy. Kinetic energy is actually nothing but vibrational energy. अगर kinetic energy बढ़ेगा तो vibrational energy भी बढ़ेगा. मतलब the vibrations are going to increase. More the vibrations, more is the space required. यानी कि the interparticle space will increase. And when that happens, the interparticle force of attraction will decrease. अब जब इतना कुछ होगा, your solid will convert into a liquid, and that will happen at something called as the melting point. In a similar manner, when you're going to shift to the process of boiling and vaporization, what are we going to do? We're going to supply heat energy. When you supply the heat energy, the temperature of the liquid will rise. The particles of the liquid will absorb the heat energy and convert it to kinetic energy. अब kinetic energy में convert किया है, मतलब vibrations बढ़े होंगे. More vibrations require more space. Interparticle space will increase. Interparticle force of attraction will decrease. And when so much happens, your liquid will convert into a gas. And all of this is going to happen at the boiling point. In hopes that you have understood the concept, all the information that you require is there onto the board. It's time for you all to take a snapshot. In the previous video, I discussed a total of two processes with you all, which is melting and boiling. Now in this particular part of the video, I'm again going to discuss a total of two processes which are going to be extremely similar with respect to each other. The first one is called as liquefaction, or you can also call it as condensation. In a similar manner, the other process is called as freezing, or you can also call it as solidification. Now understand, I'm going to discuss the first process in detail over here, and the second process over here will follow in exactly the same manner. Have a look. To start the process of liquefaction, to initiate the process of condensation, you're going to start by cooling. When you cool a particular substance, the temperature of that particular substance is going to fall. And when that happens, the excess potential energy which is there within the substance is going to release in the form of heat energy. जब ऐसा होगा, the kinetic energy will decrease. Kinetic energy मतलब vibrational energy. Kinetic energy अगर कम हुआ तो vibrational energy भी कम होगा. मतलब the vibrations will decrease. For less vibrations, you require less space. The interparticle space will decrease. When that happens, the interparticle force of attraction will increase. And when so much happens, your gas will convert into a liquid at the liquefaction point. In a similar manner, when you talk about the next process, which is called as freezing or solidification. कैसे initiate करेंगे process को? By cooling. जब cool करेंगे, the temperature will fall. और उस object में जितना भी excess potential energy है will be released in the form of heat energy. अब जब ऐसा होगा, the kinetic energy will decrease. Kinetic energy मतलब vibrational energy. Vibrations हो जाएंगे कम. For less vibrations, you require less space. Interparticle space will decrease. Interparticle force of attraction will increase. और जब इतना कुछ होगा, your liquid will convert into a solid at the freezing point. All of the information that you required is there onto the board. It's time for you all to take a snapshot. Now, it's time that we discuss the last process in this particular series, which is called as sublimation. जब भी sublimation के बारे में बात आती है, you must understand that it is a process in which a solid directly converts into a gas without passing through the vapor phase. Any kind of a solid which shows sublimation or displays sublimation is called as a sublimable solid. The examples of sublimable solids are ammonium chloride, which is given by the formula NH4Cl, iodine, which is a violet colored solid given by the formula I2, and in day-to-day life we have examples such as naphthalene and camphor, जिसको हम हिंदी में कपूर के नाम से जानते हैं. All of these solids are considered to be sublimable in nature. Now the problem with sublimable solids is कि normally किसी भी solid में the interparticle force of attraction should be extremely high. पर sublimable solids ऐसे होते हैं कि although they are solids, although their interparticle force of attraction should be extremely high, sublimable solid का interparticle force of attraction is relatively low. तो अगर आप उसको हल्का सा भी हीट एनर्जी सप्लाई करते हो, द इंटरपार्टिकल फोर्स ऑफ अट्रैक्शन जो ऑलरेडी लो है, जो ऑलरेडी बहुत कम है, वो फटाफट हो जाता है ब्रेक हो गया. मतलब तुमने उस इंटरपार्टिकल फोर्स ऑफ अट्रैक्शन को कर लिया ओवरकम, और जैसे ही इंटरपार्टिकल फोर्स ऑफ अट्रैक्शन हुआ ओवरकम, योर सॉलिड directly transfers into the gaseous state without ever going through the liquid phase. And that's exactly what we're going to learn over here. Have a look. On heating, that is on supplying heat energy to a sublimable solid. जैसे कि example है ammonium chloride. The interparticle attraction, which is already very very low, is easily overcome. In this particular case, the particles will break free and escape from the surface of the solid directly into the vapor state, यानी directly into the gaseous state. Process काफी simple है, काफी छोटा है. जितनी भी information आपको चाहिए is there onto the board. तो हम क्या करेंगे? It's time for you all to take a snapshot.
Now, to understand sublimation, I have a test tube over here, and the white colored powder that you'll see into the downward direction is ammonium chloride, which happens to be a sublimable solid. To initiate the experiment, to start the experiment, I am going to heat the ammonium chloride directly. Now remember, it's a sublimable solid. During sublimation, the solid will directly convert into a gas, and there will be absolutely no formation of any kind of liquid. The vapors that you all see right now are of ammonium chloride. And now if you all see, at the upper parts of the test tube, solid ammonium chloride is reforming, which means simultaneously reverse sublimation or deposition is also taking place. This is because this part of the test tube is relatively cooler.
So let's start the discussion about the last part of this particular chapter, which is called as the law of conservation of mass. Now whenever you talk about this particular law, there are two ways in which the law can be demonstrated, in which the law can be put forward to you all. Understand the first one. It says that whenever a chemical change takes place, the total mass of the reactants is exactly equal to the total mass of the products, provided the masses are measured under exactly the same conditions. यानी कि the conditions of temperature, the conditions of pressure और बाकी सारे conditions should be exactly the same. अगर ऐसा हुआ तो reactants के सारे mass को add up करके जो sum हमें मिलेगा और products के सारे masses को add up करके जो sum हमें मिलेगा, both of these will be exactly the same. So let's have a look. Whenever a chemical change takes place, the total mass of the reactants is equal to the total mass of the products, provided the masses are measured under the same conditions. यानी temperature same होना चाहिए, pressure same होना चाहिए, etc. But मैंने आपको बोला था कि इसी law के लिए अपने पास एक और statement भी है. Have a look. It says that mass can neither be created nor can it be destroyed. It can only be converted from one form to the other. I repeat. Mass or matter is neither created nor is it destroyed. It can only be converted from one form to the other. Now understand over here. Let us assume that I have a total of 2 reactants जिनको मैंने क्या नाम दिया है A and B. I have a total of 2 products जिनको मैंने क्या नाम दिया है C and D. If I take the mass of A added to the mass of B, मुझे मिलेगा total mass of reactants. In a similar manner, if I take the mass of C and the mass of D और उन दोनों को मैं ऐड कर दूं तो मुझे मिलेगा total mass of products. And if the law of conservation of mass is valid, the total mass of reactants will exactly be equal to the total mass of products. All of the information that you require for this particular concept is there onto the board. It's time for you all to take a snapshot. And now we are coming to the part of the video which brings you all to the end of this particular chapter. Understand, whenever we have a particular law, उस लॉ को सिर्फ तब वैलिड माना जाता है जब उसको एक्सपेरिमेंटली भी प्रूव किया जाए. तो जब हमने बात की थी लॉ ऑफ कंजर्वेशन ऑफ मास की, उस लॉ को वैलिडेट करने के लिए हमारे पास एक साइंटिस्ट हैं जिनका नाम है लैंडोल्ट, और जो एक्सपेरिमेंट उन्होंने परफॉर्म किया उसका नाम पड़ जाता है लैंडोल्ट्स एक्सपेरिमेंट. नाउ व्हाट हैज ही एग्जैक्टली डन? उन्होंने एक ग्लास अपैरेटस लिया जिसको वो बुलाते थे H shaped tube, because that's exactly how the apparatus looks like. इस पूरे ग्लास अपैरेटस में थे टोटल ऑफ 2 सेक्शंस. पहले सेक्शन में उन्होंने भर दिया सिल्वर नाइट्रेट सॉल्यूशन जिसका फॉर्मूला है AgNO3, और दूसरे सेक्शन में उन्होंने भर दिया सोडियम क्लोराइड सॉल्यूशन जिसका फॉर्मूला है NaCl. एक्सपेरिमेंट की शुरुआत करने के लिए, एक्सपेरिमेंट को इनिशिएट करने के लिए इन दोनों सॉल्यूशंस को कांटेक्ट में लाना जरूरी है. Now, the only place where they can actually come in contact is this particular connection over here. अब सिल्वर नाइट्रेट और सोडियम क्लोराइड को कांटेक्ट में लाने के लिए क्या करना है? आपको ग्लास अपैरेटस को इस तरीके से उठाना है, उसके कनेक्शन से पकड़ना है, and then you all need to swirl it left and right, left and right, left and right. और जैसे ही आप ऐसा करोगे, these two solutions will come in contact with each other और उसकी वजह से हो जाएगा chemical reaction. अब कहने की बात ये है that why should we only take these two particular reactants? यही reactants लेने से फायदा क्या होता है? Have a look. Silver nitrate is given by the formula AgNO3. In a similar manner, sodium chloride is given by the formula NaCl. जो रिएक्शन ये दोनों दिखाते हैं हम उसे बोलते हैं डबल डिकम्पोजिशन रिएक्शन, जिसमें होता ये है that the positive of the first goes to the negative of the second and positive of the second comes to negative of the first. इसका मतलब Na जाएगा NO3 के साथ और मुझे मिल जाएगा NaNO3, और इसी तरीके से Ag जाएगा Cl के साथ और मुझे मिल जाएगा AgCl. अब AgCl बनता है तो it is formed as something that we call as a precipitate. Precipitate क्या होता है? Any kind of a substance which is insoluble, यानी कि वो पानी में dissolve होने वाला नहीं है, and at the same time it is extremely heavy, यानी it will settle into the downward direction and therefore a precipitate is indicated by the downward arrow. अब जैसे ही तुम ये रिएक्शन की शुरुआत करोगे by shifting the reactants left and right, तुम्हें दिख जाएगा the formation of AgCl. जैसे ही AgCl बनना चालू हुआ, you will be able to see the formation of a white colored precipitate which will start sinking into the downward direction. और जैसे ही AgCl बनना बंद हुआ, तुम्हें पता पड़ जाएगा that the reaction is now complete. अब लैंडोल्ट ने क्या किया? उन्होंने पहले आर्म में AgNO3 और दूसरे आर्म में NaCl भर दिया, दोनों का सॉल्यूशन भर दिया और पूरे अपैरेटस को वेइंग स्केल के रख दिया, जिसकी वजह से उन्हें मिल गया टोटल मास ऑफ रिएक्टेंट्स. फिर उन्होंने एक्सपेरिमेंट की शुरुआत की, AgCl बनने दिया, AgCl का फॉर्मेशन बनना होना भी खत्म हुआ, एंड इन दैट पर्टिकुलर केस द रिएक्शन हैज नाउ कम टू एन एंड. एग्जैक्टली सेम टेम्परेचर पे, एग्जैक्टली सेम प्रेशर पे उन्होंने क्या किया? पूरे अपैरेटस को लिया और वापस वेइंग स्केल पे रख दिया और इसका वेट डाउन भी नोट डाउन कर लिया. जैसे ही ऐसा करोगे तुम्हें पता पड़ेगा that the total mass of reactants is exactly equal to the total mass of products. मतलब ये लॉ डेफिनेटली वैलिड है. एक हल्का सा प्रॉब्लम है। लैंडोल्ट ने ऑब्जर्व किया कि कभी कभार ये एक्सपेरिमेंट बहुत छोटे फर्क से, दैट इज एकदम मिलीग्राम्स के फर्क से कभी कभार अपने आप को प्रूव नहीं कर पाता है। तो उन्होंने सोचने की कोशिश की कि एग्जैक्टली ये छोटा सा जो वेट का फर्क है ये आ कहां से रहा होगा। सो ही डिवाइस्ड द फॉलोइंग थिंग। ही सेड दैट लिमिटेशंस ऑफ द लॉ आर एज फॉलो। Landolt observed a very slight error in the experiments. उन्होंने ये समझा that the chemical energy which is stored within the reactants is converted into two different forms of energy, which is heat energy and light energy. अब जब ऐसा होता है तो a very small amount of mass actually sometimes gets converted to energy. अब वो जो एनर्जी है वो हीट के तौर पे आएगी और वो लाइट के तौर पे आएगी और वो प्रोडक्ट्स में रहने वाली नहीं है, वो लिबरेट हो जाएगी। तो बहुत छोटा सा मास कभी कभार एनर्जी में कन्वर्ट हो जाता है एंड देयरफॉर द लॉ ऑफ कंजर्वेशन ऑफ मास में एक हल्का सा एरर दिख सकता है। एंड दैट इज ऑल दैट यू आर रिक्वायर्ड फॉर दिस पर्टिकुलर पार्ट ऑफ द एक्सपेरिमेंट। इट्स टाइम फॉर यू ऑल टू टेक अ स्नैपशॉट। So that brings us to the end of the first chapter of 8th standard, which was called as matter. अगर आपको ये वीडियो पसंद आया है तो definitely do give it a big thumbs up, and if you all haven't yet already, do subscribe to the channel Utsav's ChemTrek. At the same time, as far as this particular chapter is considered, if you all do have any doubts, please post it into the comment section below and I'll make sure that I'll get back to you regarding the same.